All right. So let's talk about the ideal gas law. This is a law that scientists really enjoy because it puts together like all the ideal conditions for a gas to act. Usually there's outside conditions that don't allow for that, but this is like the perfect law if everything, like the perfect pressure, the perfect volume, the perfect temperature and number of moles to get a gas to act. But because there's always so many things going on in the atmosphere, it doesn't always happen that way. So remember, we just talked about gases are sometimes measured at STP. So standard what again? What's the T? Temp. Beautiful. And pressure. Excellent, guys. Perfect. What was that number for the temperature?
273.
Which is also equal to 0 Celsius, but I like 273 Kelvin. You're going to use that. Now, standard pressure is defined as, so you're always going to use 1 atmosphere. You need this conversion, and it's also, I'm going to show you on your periodic table right here. Okay, so let's say, you will use this on your quizzes and tests. This is your very important box. So that's, let's see, 760 mmHg, or let's see how many kilopascals, 101.3 kilopascals, okay? We're going to use this a lot, all right? And I'll show you why in just a second. So in pressure, the term, so this is the term, P is the pressure, V would probably be volume. Do you remember what N is? Density, mole density. So let's do like mole. Let's just write mole. R is actually a constant. I'll talk about that in just a second. T is your temp. Thank you, guys. We call this law PVnRT. PVnRT. So if you're doing a problem and you notice you're getting a pressure, a volume, an N, R, or T, if you have all of these in your sample problem, you're probably doing a PVnRT equation, okay? So you know all of these except for R. R is this constant, again, of a gas in an ideal condition, how scientists perfectly want gases to be, but again, because of so many things going on, it doesn't always happen that way. So the R constant is actually 0.08, and just to remind you, it's actually also, where is your R? 0.0821. So if you ever can't remember R, it's on the back of your periodic table. 21, and this is very, very tedious but important, L times ATM divided by K times MOL. Oh my goodness, what in the world is that? This is the constant that you use to calculate PVnRT. All right, it is the R in PVnRT. You'll notice liters, what kind of unit is that for? Volume. So you must be in liters, okay? If you're in milliliters, just remember that 1,000 milliliters equals 1 liter. Okay, so you're going to have to convert. If you're in milliliters, you can't use that with PVnRT. Just like, you know how you can't use Celsius with any of the other equations, you can't use milliliters. You have to be in liters, okay? Do you remember what atmospheres is? Is that a pressure, N, or a temp? Pressure. So atmospheres. Remember, you might see mmHg or kPa, but if you see those, just like Celsius, you've got to get to the atmospheres. And the way you do that is, here's your conversion up here, and we'll practice that in just a second, okay? Moles will always be in moles, so you'll just see that as moles. And the temperature, remember, it has to be not in Celsius, it has to be in Kelvin, okay? So now, when you do PVnRT, you have to take 2 extra steps, right? You have to say, is my pressure in atmospheres? Is my volume in liters? And is my temperature, I think you guys are used to this by now, the temperature in Kelvin. I feel like you guys are really good at that, but it's these 2 that you might need some practice remembering, okay? So I'd like you to write this down, how to convert pressure to atmospheres, okay? Because you will see that a couple times. If given, let's say 50 mmHg, okay? So here's your example. Again, if you get stuck, you don't know what to do in your homework tonight, actually you won't get this sapling tonight, that'll be next class, but this will help, spark your memory. if you're given 50 mmHg, what you do is you start with what you're given, right? So 50 mmHg. And remember, we can't be in that unit, right? I start putting it over 1. We have to go to atmospheres. Just like Celsius, we have to go to Kelvin. Just like mmHg, we have to go to atmospheres. So what do I have to do to get rid of mmHg? Top or bottom? Bottom, beautiful. And then my atmospheres goes on top. What are my numbers that I put here? I go back up here. 760 equals 1. So 760 mmHg equals 1 atmosphere. Do you guys see where I got those two numbers? Okay, I went up here and I saw, oh, 760 mmHg equals 1 atmosphere. So what's the math that I do?
50 times 760.
So 50 times 1 divided by 760. Times 1, I guess. So 50 divided by 760 is? Perfect. So 0.065, and I canceled out my mmHg atmospheres. So that's how you convert, okay? Can you guys try this one? If I gave you, if given, let's say I gave you nice even number 5 kPa. Okay? Go to atmospheres. Change kPa to atmospheres. So take a second, try it on your own. Are people getting 0.049? Beautiful. ATM. So I start with 5 kPa. To cancel out, it has to go on the bottom on the next line. And then I convert to 1 atmosphere. Remember, if you want to get rid of something, you have to put it on the bottom. Okay? So you do have to take a couple extra steps with PVnRT, but I think once you get the hang of this, you'll kind of understand it. Okay? Okay, so now let's try example 1. What is the volume? And this is how I attack these questions. I always put the variable on top in the question. So what is the volume, so that's a V, of 1.54 moles. So that's my N in my PVnRT. At 25 degrees Celsius, that's my T. And a pressure of 684, so this is my P. Okay? So what do you notice right away is wrong with this problem? Who could pick out the things that are wrong? Ethan, what's one thing? R, you're right. It doesn't say what R is, so just assume R is given, and that's equal to what? 0.0821 liters, atmospheres, K, moles. Okay, so R is given, so always assume R is given. Okay? What else is wrong with this? What do I have to fix before I start this problem? Peter?
Change the Celsius to Kelvin.
Yeah, how do I add 273 to 25? 273 plus 25 equals 298. So this is really 298. Okay, and what else do you notice? The pressure is in mmHg. What does the pressure need to be in?
ATM.
It has to be in ATM. So to do that, 684 mmHg over 1. So again, mmHg, top or bottom?
Bottom.
Beautiful. To atmospheres, what are my numbers? I go back up top. 760 mmHg to 1 atmosphere. So that equals, so 684 divided by 760.9 atmospheres. Oh, finally I can start with this problem, okay? So I'm going to use the equation PVnRT. So what's my P? 0.9. So set it up as, so PV equals nRT. So the P is 0.9. The V is what? Oh, we're solving for the V. That's my X. Equals N. So what's my N? 1.54. R, we said, is 0.0821. And my T is 298. 298. So see how now this is this math you could do, right? So we're going to multiply 1.54. So go ahead and do that. 1.54 times 0.0821 times 298 equals 37. And then divided by 0.9. Are people getting 41.86?
4.1.
Okay. Okay, we're good to go. Let's look at the next one. And then you guys are going to work on the back page. Let me just do one more example. So how many moles, so that's an N, of propane gas will be present? Milliliters, what unit is that in PVnRT? A PVnRT. V. Temperature, so this is a T, and the pressure, so P. Is there anything wrong with my units? Tristan?
Change the temperature to kelvins.
Okay, so 35 plus 273 is,
308.
thank you. So this should really be 308 Kelvin. Anything else? Is everything else good to go?
The volume.
Yes, good catch. So the volume, 2390 mils, what does it have to be in? It can't be in milliliters, it has to be in liters. So remember, up here, 1,000 milliliters equals 1 liter. So it's 2390 divided by 1,000, which equals 2.39 liters. Is everything else good?
Yeah.
I think so. Yeah, you're right. So P is, again, PVnRT, 15.1. V, what's my V? 2.39 equals N, which is, that's what we're solving for, X. R is 0.0821. And T is 308. Okay. So 15.1, nope. 15.1 times 2.39 equals, so 36.089. 0.0821 times 308 equals, that's
I
my,
have a question.
yes.
You know how when we have quizzes and we have to do this and there's like extra information?
Yes.
Is there gonna be that?
Not on any of these problems just yet. Yeah, so good question. Especially in ACT, you'll see a lot of that, like extra information, stuff that doesn't matter. You won't see that in here. Everything in here is important, but what you gotta do is ask yourself, am I in the right units? Okay, am I in atmospheres? Am I in liters? You guys know Kelvin, you got Kelvin down. But the liters and atmospheres, you're gonna have some trouble with because it's new. So divided by 25.2, what are people getting for this?
1.427.
1.427?
Yes.
And the units here, because it's moles, is just gonna write moles, okay? And what are my units here? I'm leaving them naked, I feel so horrible. Okay, so this one, example 1, 4.186 liters. Example 2, 1.427 moles. So 2 big steps. PVnRT is the equation. Am I in liters? Am I in atmospheres? If not, I must convert. Okay? I know this is a lot. I know it's a lot. So I really appreciate you guys working hard today. But you can do this. All right?